Okay, an important distinction is annuities have periodic payments, and if you're simply using compound interest, it's a one-time deposit where you walk away and go back much later and get a bigger chunk of money. But periodic payments, so like this says a monthly payment, that's going to be monthly, and the payment has me dealing with an annuity. This is a weekly payment, this is going to be weekly, so we're going to make a payment that way. So each is an annuity. Because that's monthly, 12 times a year, we're going to use lowercase n is 12. Because that's weekly, we're going to use lowercase n is 52. All right, so what is the monthly payment to have $23,500 in an account after 6 years at 5.1% APR? So it's monthly, so they're going to go in a bunch of different times. And we're going to make a small payment compared to the $23,000 that we're going to have. Let's go find out what it is. We're looking for the payment that we're making, so we're doing one of these two things, and we're looking for the payment because we know the amount that it's got to be. It's not that we know the payment that we're making, we want to see what the account is going to be worth, so the P equation. So now we have to find A, R, and N. A is where we want to be, $23,500, straight up done to go in like that. R takes a little bit more work. It is going to be 5.1%, so percent divided by 100, and this is a monthly payment, so it doesn't just happen once, it happens 12 times a year. And for that purpose, I'll put that N equals 12. They didn't tell us that. That's why I'm putting it here in red. N equals 12. And then for the number of periods, it's going to be 6 years, but it's not just once a year. It's 12 times per year, so 6 times 12 get me 72. Let's look at what happens when we do 5.1 divide by 100 and then divide by 12. 5.1 divide by 100 and divide by 12. 0.00425. Okay, we can work with that. 0.00425, and there was room for more digits to be on my display, which means that that is a perfectly completed, right, terminating decimal. And now what we want to do is find that P is equal to, and we want to do this stuff. A is $23,500. R is 0.00425. And the denominator is made up of parentheses around 1.00425, because it does go right in, adding the R to 1, will be raised to the power of 72, and then we'll subtract 1 from it. So for the numerator, I have 0.00425 times 23,500, and the numerator is 99.875. And that's perfectly completed, right, as what the numerator will be. It's not got these decimals that are twisting in perpetuity. So what I now want to do is figure out what the bottom is, where I have 1.00425 raised to the power of 72, and then from that I'm going to subtract 1, and I'll come out with 0.357, 102057, and I've taken all of them to see what I can get here. So I'm going to go ahead and I'm going to take the 99.875 and divide by the denominator. And come out of here with 279.681. 681 I said, so why didn't I write it correctly? That sounds like a good idea. 681. 81 becomes 80, and that's why I would say that I could go 279.68 by rounding it to the nearest penny. In reality, I might go 69 cents and have a payment that exceeds, so that the last payment can be a little bit less, and I'll meet my goal. So that's where that one is and what we had to do with it. And in that case, we had the good fortune of having 0.00425 landing in our position for the periodic rate. Now we're going to do a similar problem, but the periodic rate is going to need me to stretch out the use of my calculator. So here we have one where we're going weekly. Find the weekly payment. See, up here we had a monthly payment into an annuity. Here we have a weekly payment. So that means n is equal to 52. We're going to do the same kind of stuff here. We're going to need to know, what are we trying to reach? A is 2.8 million, so we go 2.82 comma 800, and then 3 more zeros, so it's 2.8 million. Interest rate 9.05. Has to be divided by 100 for percent, and that I could handle as a decimal. But then when I wind up dividing it by 52, I'm not so sure that'll divide evenly by what 52 needs to have happen. So we'll see. I'm going to go 9.05 divide by 100 and divide by 12. And that's 0.075416666, and it looks like the sixes want to go on forever. So I'm not going to write that as a decimal. I'm going to put it into the calculator using parentheses. And n is equal to 36 years times 12. 432 payments. Nope, not 12. Why would I say 12? That's silly. This is weekly. So in comes purple times 52 payments per year. 36 times 52, 1,872. All right. I guess I got monthly on the brain because car payments, mortgage payments do tend to be monthly. We do get in that pattern saying, here comes a 12, here comes a 12, just like in algebra, you're so used to putting X. But that is a weekly contribution to try and get to 2.8 million. All right. So now we have a lot of the same stuff here. We got P is equal to, we've got to put our 2.8 million to 800 and then 3 more zeros. And then we need to put, right behind that, we got to put R. So in there, what's going to show up is going to be all of this. 9.05 divide by 100 and then divide by 52. And we'll let that make what it makes in terms of a decimal. And down the bottom, we have this, right? We don't necessarily need that, but that'll be there for me to go 1 plus 9.05 divide by 100 divide by 52, close it, and power it up to 1,872 before we subtract 1 off the result of that. So let's figure out what the numerator is going to make. 28, and then 2 zeros for 2,800 and 3 more for 2.8 million, times 9.05 divide by 100 divide by 52 equals 4873.0 and it's got 76923 $, and that's as far as I can take it. So that's as much as I can write for it, because the denominator is going to have work as well. It's going to have me writing the decimal places. So what I have for the denominator is, when I clear out the top, 1 plus 9.05, which is divided by 100% and divided by 52 to get weekly. It gets me my 1.0, some my 1.0001740385, and there's more going on beyond what the display can show. But I took care of the parentheses, which now must be raised to the power of 1,872. And whatever that makes, I'm going to subtract 1 from. My denominator, 24.923 97477. And now what I'm going to do is enter both of those values, set up the fraction, and do the division out and see what I come out with. So I have all those decimals doing work for me, and I'll see where it winds up with dollars and cents. And so I'm going to do 4873.0 0.076923. And we'll divide by the denominator as you see it. And we'll get $195.517. $195.52. That'll be the payment that'll get me there. I gotta do it every week. I gotta do it for 36 years, but it'll get me to where I plan to be. Now I want to show what happens if you don't take enough decimal places to this. It's not horribly wrong, but it won't get you the right accurate down to the pennies. Let's say that I take 4873 and I just go with that, 4873, and I decide that I'm going to divide that thing by 24. It says $203.04. So if you didn't take enough decimal digits into play, you might have yourself putting away $203.04 instead of $195. That's an extra $8 a month. So you're going to be putting away too much. You'll then surpass the 2.8 million and have more money, but by not going as far as you possibly can, you run the risk of rounding too much and getting something that's not accurate for what you're trying to get done. So that's why we have to push the decimals as far as they can when they run off the display that we have. So we have other ones here. Okay, we're going to now find the value of paying 62, it's the future value of putting $2,600 quarterly into an account. That account is an annuity. You're making deposits to an account over time at 6% APR. We want to find the value of the account, so we're going to use this formula. That means we need to know what P is. What's the payment in? How about $2,600? That's good. How about capital R? R is 6% APR. So 6 divided by 100, so that's for percent, and then it's done quarterly, so we'll divide by 4. And N is, this guy didn't say, for 4 years. So N is equal to 4 years times 4 quarters per year for 16 payments. And now what we're going to have is the account value in the future will be the 2,600 times the square brackets that contain this value. We're going to figure out what the 6 divided by 100 divided by 4 is. So we take 6, divide by 100 for percent, and divide by 4 for quarterly. 0.015. And so now 1 plus 0.015 is 1.015, which I can keep in the parentheses, raise it to the power of 16, subtract 1 from that. We'll be able to do our numerator work. And in the denominator, all we have to do is put 0.015. Okay, so we got lucky in the sense that it's easier to work with the 0.015 than the parentheses that we sometimes have to deal with. So for the numerator, we're going to have 2,600 times a pair of parentheses that contain 1.015 raised to the power of 16. Then we're going to subtract 1 from that value before we close our parentheses. Those parentheses represent the square brackets. I've done it now times $2,600, and I get $699.3624. 239. And I need to divide that by 0.015, so I'll leave that in my calculator as I now go to divide by 0.015. And I come out of here with the account value is approximately, so let's make that squiggly, 46,624.161, or rounding off, $46,624.16. Okay, you might have 1/10 of a penny more, but then when we round it off, that's what you'd actually have. You wouldn't get that 1/10 of a penny because it don't go that low, and that's what it's worth. So here we're going to see what's the big number this is becoming worth by putting a little bit in 16 times. $2,600, not a really tiny amount of money, but nor is 16 a ton of payments. It does get to be $46,624.16. Now this one here has 2 parts to it, and a lot of times people have trouble with this one because it's not a direct, like, he said to do this, I do that, I get it right situation. This requires insight on your part as to what is going on. So I did decide to put this in the homework practice because many times in the past students have gotten confused by Part B. So we'll see what happens. Determine the value of an account to which you pay $6,000 annually at 13.5% APR for 6 years. So this is annually. Because it's annually, it's just once a year. Therefore, N is equal to 1. And I'll put that in red for us when we need to do that. But we're looking to find here, what is the account going to be worth? So we're going to be putting in P, R, and N, and therefore we better know that P is $6,000 going in once a year. R is the interest rate, 13.5%, means divide by 100, and it's going in annually. So if we see this division by 1, that's why this gets to just stay 0.135 when we divide by the 100, and that will go in that way because it's once per year. And now our N, number of periods, is once per year, but it's 6 years. So 6, if you want to multiply it by 1, you'll see that it still stays 6. And we're trying to find A. So A is equal to, and we're going to go putting in P of $6,000. And then we're going to go in the square brackets, we're going to have 1.135. I'm going to raise it to the power of just 6. And we're going to subtract 1 from that. And in the denominator, we have R represented as simply 0.135. So we can determine what the numerator is on our calculator and then divide by the 0.135 here and get our value. So I'm going to go 6,000 times a pair of parentheses, which are the square bracket. Then I have 1.135 powered to 6. And then I'm going to subtract 1 from whatever that made and close my parentheses. Now, if I look at my calculator, it's saying something that you don't have to see, 1.137839855. I'm not done yet. I have to hit equals to bring in the multiplication by 6,000. 6827.039. But I should get all of it. Dollars. 6827.039129. That's what I'm representing, but the good news is my denominator is simply 0.135. So I'm going to divide what's sitting here by 0.135. Get my value. 505.70. $50,570, $50,570.660, which is 505.70.66. And that's what happens if I put in $6,000 a year across the 6 years. That'd be the end of a normal problem, but this is going to say, let's look at other options. Suppose you also had the option to do this. Determine the future value of an account when you put all of the deposits, the total, into the account for 5 years with the same terms. You are not putting them in a little bit at a time. You're going to take all of the payments and put them in once and then leave them there. So that's going to go to the other form where we have compound interest, principal times 1 plus R to the power n. Now, what is principal here? Well, P is the amount of your own money. It's not a single payment, it's all your payments, right? So what we have ourselves doing here is you put in 6 payments for, let's see, for 5 years, all the account for 5 years. So you're gonna do 5 years of payments at $6,000 each. So that's gonna be not just $6,000 a single time, but a $6,000 5 times. That's as though you have $30,000. Because it says over 5 years you would have done 6, 6, 6, 6, and 6,000 for 30,000. Somehow you got hold of it all at once. 30,000 is your principal for P here. R is going to remain the same for the same reason that it did before, was 13.5 divided by 100. Right, you're going to get 0.135 for your value for R. And now N is 5 years. You left it in for 5 years. You didn't leave it in for 6 years, but you left it in for 5 years, and if you multiply by 1, you'll get the 5. This is comparing a situation where you have compound interest of one big deposit with an annuity, where the interest rates are the same. That's 6 years, that's 5 years. And so we get our account balance in this case is 30,000 times 1.135 raised to the power 5. Let's see what that equals. 30,123 times 1.135 raised to the power of 5, and it comes out as 56506. 0.780. 56 506.78. That amount. Then you might be asked, which is a better outcome and by how much? And you would subtract and say that the one where we had the 30,000 sitting in all that time was getting you more money at the end, right? But which one earned you more interest? Let's take a look at that. The interest on the first one was going to be 50, 570.66, and there you have to subtract 36,000. So we get 14,570.66. And on the other one, you have 56,506.78. And in that one, all you had deposited, although you did it all at once and early, was 30,000. You get 26,506.78. So it's better to have all the money at the beginning and have all of it working for you the whole time to make more money. But we don't always have the money right away, so we often have to go to annuities and put money in over time. We're going to look at one more problem here. Question 5. So you deposit $4,000 for 4 years into a CD, paying 4.9% APR, and it's compounded quarterly. Let's find its future value. So this is when we're going to an annuity, and we're going to put in payments with a certain interest rate for a number of periods. And so we need to know what P is, what the payments are going to be. No, you know what? Common mistake. Just almost fell for it myself. Let's see. You deposit the $4,000 all at one time. So it's not $4,000 each time, it's $4,000 once at the beginning. Still we need payment, but it's going to be this one, a single payment. So P is going to be $4,000, but it only goes in once. Okay, next thing I come across the need for is R. R is 3.9%, so percent is divided by 100, and it's going to be compounded quarterly, so we're going to divide that thing by 4. And then finally N, we have 4 years times 4 times a year with quarterly to get 16. So now we're going to come out of here with our A equals our initial principal of $4,000, that was our own money, times 1 plus. Now this R of 3.9 actually does become a terminating decimal. And so I'll turn on the calculator and go with 3.9. Dividing by 100 I know is still going to stay with a terminating decimal. And when I wind up dividing this thing by 4, come out with 0.00975. So that's good. Because it terminates, I can put it right behind my 1. 0.00975. And that's all of what R makes of itself. Raise it up to the power of 16, and we'll see what we get. So we got 4, 1, 2, 3 for 4,000, then times 1.00975, and raise it to the power of 16. Come out of here. 46.71 and 77 cents. It's 46.71 and 77.3 cents. So there, we'll get 77 rather than 78 cents, and we'll have that value. Now here's where we go for an annuity instead. Now what happens is this annuity pays 6.5% because the annuity rates apparently went up over time. So not putting all your money in at once and locking it in at 3.9% allows you to take advantage of the interest rates going higher and paying you more. The way that happened was we broke up the deposit into quarterly payments over the 4 years. So we have 16 payments that we have to make. Therefore, what we're going to do for our payment is we're going to start with our original $4,000, but divide by the 16 payments and get $250. So that's what we're going to go in with for our principal. And besides that, we need to have R, but in this case, R is 6.5, divide by 100 for percent, and then that's going to go in quarterly, so we're going to have to divide that by 4. And of course, N here is equal to still 4 years times 4 quarters per year for 16 payments. So we're going to apply this formula here. So we've got A is equal to, we've got our $250, and we'll figure out what 6.5 divided by 100 divided by 4 is. 6.5 divided by 100 will surely be a turning decimal, and then divide by 4. 0.01625. And because that terminates before I run out of digits on my calculator, I can enter that right behind the 1. 1 plus that will get me 1.01625. I'm going to raise that to the power of 16, and then I'm going to subtract 1. Should be a square bracket, that's fine. Okay. In the denominator I have R, which is nicely 0.01625. Alright, so got my 0.01625. I'm going to go with 1 plus that for my base. So that 1.01625, raise it to the power of 16. 16th power. And then what that results in, I'm going to take off 1, and that equals 0.29422 for 475, and I'm going to multiply that by my 250. You got $73, and it's 555,61896. All that sits on my calculator, and I'm going to divide that by my 0.01625. Four 526. 526. 0.499, so 0.50. Second answer. So now, which one is the better value for you? In this case, it's going to be the CD, because we get up to that 46.71 rather than 45.26. We'll take the CD option by putting it all at once. Even though that was at a higher rate, because the money went in slowly, it did not catch up over the same amount of time to get me as much of a balance or as much in interest. Now we'll wrap that up.